What two things? Basically, how does it work? Yeah, PNP, NPN, PNP, NPN. So if you understand how this guy here works, you understand a bipolar junction transistor. You understand a transistor. What is this? This is a water valve. What do you do with water valves? What do you do with water valves? You control the flow of water. What does a bipolar junction transistor do? It's a current valve. You use it to control the flow of current. What device, what device did you learn in DC that we use to control the flow of current? Huh? Learned it in DC. Yeah, right. It's a resistor. But a valve, we have the ability to control the flow over a range. So a resistor, what does a resistor do? It controls the flow of current, but it's not adjustable. A transistor is adjustable. So what device did you learn back in DC that you can actually adjust the flow of current? Rheostat. A rheostat's got a knob on it. That who turns it? You turn it. A transistor don't have a knob, so it is a rheostat that you electronically control. If you understand rheostats, then you got transistors down. It's just that a rheostat, I have a knob on it that I turn, right? You understand? Or something mechanical turns it. A transistor, you control the size, the opposition to current with a third lead. So we got three leads. What's the three leads? This is with the arrow on it. We call this the what? This is called the emitter. The other one is what? Collector. There's your valve right there. So what we're doing, if we deal with electron flow, this is the valve right here. There's the valve. Then we call this lead right here the what? What's this called? This is called base. So the base sets the size of the valve, but we're doing it electronically. So anytime we deal with electronic devices, normally we have to talk about bias, right? You understand? Forward and reverse bias. So I look at this symbol right here. And the arrow is not pointing in. So this is an NPN transistor. A PNP transistor, the arrow would be what? Pointing in. Pointing in. And then you have to make up the P. And all this deals with the polarity of the voltages that these two guys operate on. Usually a PNP operates on a negative voltage, an NPN operates on a positive voltage. Now we can do that and connect the leads different, but generically speaking. Are we okay? So I've got a stereo amplifier that I want to amplify AC. Then what we would do is up here, I would use a NPN and connect it up to plus. Then down here, I would use a PNP and connect this up to minus. Oops, sorry guys. And then I take my stereo speaker and I would hook it right there. So now this guy here would turn on, would give me a plus. This guy right here would turn on and give me a minus, and I can get AC out of DC, right? You understand? But one of them's got to be a what? A PNP, and the one that's got an NPN. So normally an NPN operates on on positive DC, and a PNP operates on negative DC. So to make this thing work, we have to bias it. How do we bias it? So we can run these things in 3 regions. What are the 3 regions? Anybody know? Huh? No. We can operate it in saturation. In saturation, it acts like a closed switch. We can operate it in cutoff. Here it acts like an open switch. Or we can operate it in what we call the active region. Here's where it actually acts like a rheostat. So in digital, we switch it between saturation and cutoff. The digital is basically 2 states. So all your computers and all this other kind of stuff that's digital, it's got thousands and thousands of transistors in there, but they're all either what? They're either saturated or they're cut off. Now your stereo, when you hit those speakers, that's analog, right? You understand? Your stereo itself might be digital, but when it hits the speakers, those speakers are analog devices. So we're going to operate them like a rheostat. Now, how do we forward bias it? Well, the symbol tells you how it forward biases to make it operate. N, P, those are the positive. So what do? It means, I drew that as a comment. I didn't mean to do that, guys. So to turn this thing on, the first thing I'm going to look at is my base to emitter, this junction right here. So there's nothing but a diode right there. And it's in there just like that. That's all it is, a PN junction. So the forward bias of a PN junction, I'm going to have to make the base positive in respect to the emitter. It could be positive or it could be 0. Or it could be negative. Y'all understand? That forward biases that junction, which is going to cause what we call a base current to flow. So I could come over here. By the way, once you turn the thing on, it acts like a short circuit. So if I was going to do this, I would set up a battery. I'd have to put a resistor there because it's going to have to be greater than what? If it's a silicon transistor, then this right here is going to have to be greater than what we call 7/10 of a volt. Of course, when we did that lab, we understand it's approximately 7/10, right? And then I would have to come over here. I would put a battery like this, and I would come over here and connect this to the emitter. As soon as I did that, the diode's forward biased, and what would happen? Well, we would come over here and we would have a current flow. That's my phone in there. You know, I left my phone. Okay, guys, how do we make this work? Well, to make this work, you have to reverse bias the base to collector. So this would be positive by 7/10 of a volt. This right here would be a lot more positive. So I would come over here and I would put another power supply. I'm going to have to put another resistor. We're going to call this the collector resistor. And this is going to be a bigger battery. Now, as soon as I have base current, what does that do? That opens the valve up and it allows the main current to flow in this direction right here. Very little base current, a lot of current over here. If you don't have base current, you don't have collector to emitter current. Now, which is the highest current in the transistor? Yeah, which is going to be the highest current? Emitter current, base current, or collector current? Well, the emitter's got two currents flowing through it. It's got base current and it's got collector current. It's got collector current flowing through it, right? You understand that? So the little formula is IE is equal to IB plus IC. But for all practical purposes, over here we might be dealing with milliamps. Over here we might be dealing with amps. So for all practical purposes, we're going to assume that IC is equal to IE. Is that true? No, I'm going to put a little squirrely line. It's not true. Which is the highest current? The emitter current. It's the sum of the base current and the collector current. So then IC would be equal to IB, or let's rearrange that. No. IC, I'm dealing with IC. It's going to be equal to IE minus IB. And of course, IB would be equal to IE minus IC. But what we're going to do is we're going to take a really, 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 really small base current to control a large collector current. Now, the ratio of the base current to the collector current is called beta. Data sheets, you won't see this. They refer to it as the 4. So we'll look for H of FE. That's the beta of the transistor. And it's equal to IC over IB. The transistor we're dealing with, the 1N3904, this has a typical beta of around 100. So what that means is if I put 1 milliamp of base current in, I would get 100 milliamps of base current out. If I took 2 milliamps of base current in, I would get 200 milliamps of collector current out. Now my emitter current would be equal, it's got a beta of 100, right? If I put 1 milliamp in, I get, so that my emitter current would be 101 milliamps. So my collector current would be 100 milliamps. My emitter current would be 101 milliamps. So for all practical purposes, for design and calculation, we're going to assume that the base current and the emitter current are equal to each other. But notice, how many batteries does this take? 2. We'll find out later on how we can bias it with how many. 1. So when we get back in, we'll hook this thing up on an electronic workbench and let y'all see this thing operate electrically, how it works. We'll measure the base current, we'll measure the collector current, we'll measure the emitter current. And what I'll do is I'll make this guy right here adjustable. If I make that adjustable, then what does that mean? I can adjust the amount of current. This resistor right here will drop whatever. This guy right here is actually setting the current, right? You'll understand that. Because if you ever got it to 0, you'd burn your transistor up. So it'd be easier to put a fixed resistor there, so you know you always got R no matter where the power supply is set up. This makes it a little hard to do on our trainers because our trainers are set up like this. It's got 2 power supplies in there, and that right there is common. So that, and then this right here would be the little block labeled what? Plus, this right here would be the little block labeled what? Minus. Well, right here, to do a PNP, I need a plus and a plus. So this one, notice here the negatives are common. So that means when you do this lab, you can't use the power supplies on the trainer. You can use one of them, but you're going to have to use an external power supply as the other. Y'all see what I'm talking about? Yes or no? So notice here what's common on these. Well, minus, plus are common over here. When I look down here, what's common? Minus, minus. So that means you can't use the two power supplies that's on the trainer. But what they do that for is that here I can get around 15 volts. Here I can get around 15 volts. This would be plus 15 volts. This would be minus 15 volts. So what? 15 volts. So how many volts can I get out of the trainer? Well, I can use one power supply to either get a minus 15. If I go across the two, then I can get what? I can get 30 volts. And then it's up to you to establish the common. Minus, plus, difference in potential. What's the difference in potential between a minus and a plus? Well, I'd say 15 minus a minus 15. What are you supposed to do when you subtract negative numbers? Change the sign and add. So that'd give me what? 30 volts. So that trainer, if we go across the two power supplies, we can get up to 30. Oh, well, it's actually over that, 30 volts, right? But we can't use it for this because here, what's common down here? The negatives, what's common up here? One of them's got a negatives common and the other one's a positive common. So we got plenty of power supplies, guys. You know, when we broke over that diode in there, we got plenty of power supplies in there. Okay? Okay, guys, see y'all Wednesday what we're going to do with the test. Mamas and papas, Monday. But whenever Monday comes. Nancy did. No, I'll get you though. Yeah, Nancy. Well, she bought 4 bottles. We went to a brewery. It was really neat. We went to a microbrewery and we went to a full blown brewery.